Hey guys, this is Coach Brian making a quick video over some of the questions on the 5.2 practice. Today is all about isosceles and equilateral triangles, and that has to do with the types of triangles and more specifically their sides. So when we're looking at an isosceles triangle, when we're looking at an isosceles, that's a horrible triangle. Let me redraw that. When we're looking at a isosceles and isosceles triangle, two of the sides of it are going to be equal, Two of the sides of it are going to be equal. And then when we're looking at an equilateral triangle, don't trust my drawings here, but on an equilateral, all three sides of it are equal. So those are the first kind of two types of triangles that we'll be studying, and that knowledge will be helpful for us as we go and solve for some missing variables and angles and lengths and sides and all that stuff. So questions number 1 and 2 ask us to find each angle's measure, the measure of each angle. And for the first one, it's asking us to find TRU, which is TRU. It's this angle right here. We're trying to figure out what the measure of that angle is. Now, this is kind of the easier of the two out of 1 and 2, so I'm actually going to work number 2, which asks us to find the measure of angle A, this angle right here. And from our notes, we know that when two sides, I'm going to highlight them in blue, when two sides of a triangle are equal, that the angles opposite of those sides are congruent, The angles opposite the sides are congruent. And so what that lets me know in this particular question is that angle A is congruent to angle B. And so to solve this, it's helpful to know that those are equal. So I could just put 6y plus 1 for A also. But now I actually want to know what y equals so that I can plug it in and figure out an answer in degrees for A. And so one thing that I do know is that all of the angles inside of a triangle, I'm going to put this one with 2 little marks because it's different than the others. I know that all of these angles, A, B, and C, add up to 180 degrees. So using that knowledge that A and B are equal and that A, B, and C together equal 180, I can actually make an equation that just adds them all to each other. So there's A and B, and then I add in C, and I know that all of these together equal 180 degrees because all the interior angles of a triangle add up to 180. And so what I can do on this side is combine like terms. I've got 6 y's, 6 more y's, that's 12, 21 more y's, that's 33 y's, 33 y's that I get from combining like terms right there. And then for my whole numbers, I've got 1 plus 1 plus 13, so that's 15, and together those equal 180 degrees. And now algebraically, I can just subtract 15 from both sides, leaves me with 165, and 33y over here. Then I would divide both sides by 33, and y equals 5. So that's really helpful, although it is not what the problem asked me to solve for. Ultimately, the problem asked me to solve for the measure of angle A, which means I need to take this y equals 5 and plug it into the equation for A. So instead of 6y plus 1, I'd have 6 times 5 plus 1. 6 times 5 is 30, plus 1 is 31. So angle A is 31 degrees. 31 degrees. As I go down to 3 and 4, it just says to find each value. So in question 3, I'm looking for I'm looking for BC, the length of BC. And in question number 4, I'm solving for y. What is y? So the first little given right here is to assume that triangle BCD is an equilateral, which means all of its sides are equal, and that also means all of its angles are equal. Okay, all of its angles are equal. So that's really helpful to know that all of its sides are equal. And since I do have 2 of those sides, I know that BC is 6x plus 8, and I know that C to D is 5x plus 24. Whatever BD is, it's also equal to these 2, but I don't really need it to solve because I can just take these 2 that I do know and set them equal to each other. And I can take 5x from both sides. And that's nice because it leaves me with an isolated x. Subtract 8 from both sides. And x equals 16. So again, that's really helpful to know, but that's not what the problem is asking me to solve for. I now need to take that value and plug it in so that I know the side that I'm looking for. So 6x plus 8 with x equals 16 would then become 6 times 16 plus 8 equals whatever BC is. And if I start working that out, 6 times 16 is 96 plus 8 equals 104. Now again, I don't know what the units of that are, okay? I don't know if that's inches, miles, I'm not really sure about the units, but whatever they are, it is 104 of them. 4 is similar. As you can see, it is an equilateral triangle, and you're trying to solve for y. So I'll let you work through and figure that one out. I'm going to move ahead to 5 and 6. It says find the value of the variable in each diagram. So in number 5, I'm looking for y, and in number 6, I'm looking for x. And these are some interesting problems because even though it looks like you may not have a lot of information, it actually is giving you quite a bit of information. The first thing you know is that anything with a little mark on it in the image is equal. Okay, it is equal. Also, angles that have similar markings. See how these both just have one line? Angles that have similar markings are also equal. So that's, again, really, really helpful to know. All right, so if I'm looking at this triangle, I know that this angle right here, I'm going to make it green. I'm going to put 2 marks for it. I know that it's 40. And then I've also got this other, like not quite known angle. I just have an expression that represents it. And it's 3y minus 5. So if you're like working through this, you're like, man, is there any way I can know what these angles are? Well, if you look, kind of just ignore this side for now, okay? If you look just at the right triangle, and by that I mean this one, the one on the right, it's got 2 sides that are equal. So then what you know is that the angles that are across from those sides are also equal. So these 2 angles that I've put in this like maroon color, I'll add a 3rd line so that it's very clear what I'm talking about. Those 2 angles equal each other. They equal each other. And on the other angle, okay, the other triangle, I'm going to use a different color here. These 2 sides also have marks, which means the angles opposite that are equal. So that's like a big kind of clue right there, okay? If all of the interior angles of a triangle add up to 180, I know that this angle and this angle and this 40-degree angle equal 180. So let me start with some math. Now, I've got 180 degrees, and I know for sure I've got this 40-degree angle. And that leaves me with 140 degrees between these two. And if they are equal, which I know because of the opposite congruent sides, then I know that that 140 degrees has to be split evenly between them. Okay, it has to be split evenly, which means I could divide that by 2, and that means each one of these, let me put them in a dark color, are 70 degrees. Now that's like hugely helpful for me. All right, that's really, really helpful for me, because I now know, because of my matching markings, that this angle is also 70 degrees. And if it's 70 degrees and the other two are equal, that means they are going to be, whatever's left over from 180 minus 70, which is 110. And if they're equal, that means they are both 55 degrees. I hope this is making sense. All right, and then the very last thing is I can use this expression, knowing that it is 55 degrees, I can add 5 to both sides, and that leaves 3y equals 60. I can divide both sides by 3, and y equals 20. All right, so I think that's enough to get you going on your practice. 6 is similar to number 5. And then I want you to think about 7, 8, 9, and 10, and let me know if they are sometimes true. That means you can find some situations where it is true, but you can also find some where it's not. Always true, this means you can't find any way to prove it wrong. Or never true, which means you can't find any way to prove it right. All right, good luck on the rest of your practice. Reach out to your teachers if you need some extra help.